Section 9.2, the critical value approach to hypothesis testing. So in this section, we are actually going to see actual numbers to convince ourselves if we should reject a hypothesis or not. Again, this will be basically testing a claim, regarding the population mean mu with a standard deviation known to us. And this method is called the classical approach method. And in the next section, we will show you, we call it the p-value method. And so if a claim is made regarding the population mean with the sigma or standard deviation is given, we can use the following steps. First, the way it happens that a sample is obtained from simple random sampling. So there's a sample using simple random sampling method. You group that sample, making sure the sample has no outlier and the population is normally distributed. So the population where the sample was chosen or taken is non-distributed, or n, the sample size bigger than or equal to 30. If these things are done properly or this way, then we first start by stating the claims. Claim that is made regarding the population mean. We start making the stating the claims, and it's going to be one of the ones I told you is going to be either two-tailed test, where you write h0 is mu equals mu sub 0, h1 or ha, mu does not equal mu 0, and then we do the same thing. Is going to be if it's right-tailed or left-tailed. You know how to set them up from the previous section. With this, we are going to have, we call it the level of significance alpha, because we're going to be using it. We only introduced it in the previous section. Alpha will be given to us based on the seriousness of making a type 1 error. That's what this was for. And then what we do, we are going to find the z value. I'm going to call z sub 0, which is x bar minus mu divided by the standard deviation over the square root of n, because x bar would be given the population mean over the standard deviation divided by the square root of n. This is called test statistic. And we are going to find another z value, z sub alpha. It depends if it's z sub alpha or z sub alpha over 2. This is for the two-tailed test. And the first one either left or right. Then what happens is, if we look at the graph, the three cases, if we have, which we have it actually constructed down here, this is for two-tailed test. Okay, these regions, the highlighted regions, are called critical region, or I call it rejection region. And this applies to the other two graphs, the left-tailed and the right-tailed. Now that we have two values here, two things to find. The first value is z sub 0, the classical t-test value. And then the other value, we're going to have z sub alpha. And how do you find z sub alpha? Alpha would be given. Then we use table 2, if you remember, table 2, to find the z value. And then we compare them. We're going to see. So the way this works is we are going to place the z sub alpha, okay, z sub alpha on the graph, on these graphs, okay, and what happens, maybe if I draw it from scratch, it's easier. So let's say we have it the right tail test. So this is Z sub alpha. Z sub alpha. And since it's a, let's say, right tail test, so that would be the rejection region. That would be the rejection region. And then remember, we found two values of Z, the test statistic value and the Z sub alpha. After we find Z sub 0, if Z sub 0, the test statistic, falls in the rejection region, like in the highlighted region, in the rejection region, we then reject the null hypothesis. If it falls in the other region to the left of C sub 0, we fail to reject the null hypothesis. We do not reject it. That's called the classical approach, because we are finding the classical or the test statistic value Z sub 0. I'm going to show you an example. This is not difficult at all. The example states that according to the U.S. Federal Highway Administration, the mean number of miles driven annually, is 12,200. Patricia believes that the residents of the state of Montana drive more than the national average. So she's kind of like a, let's say, researcher. She thinks that the mean should be more than that in the state of Montana. She obtains a simple random sampling of 35 drivers. So the sample size she obtained is 35 from a list of registered drivers in the state of Montana. The mean number of miles driven for the 35 drivers is the mean. So X bar is 12,895.9. Assume the standard deviation is 3,800 miles. And Patricia wants to test the claim at the level of significance alpha 0.1. So let's see if she's gonna reject the null hypothesis or not. Okay. So how do you do this? The first thing I always do is I set up the hypotheses. Notice I put H1 or HA the same. H0 is that the mean is given to us as 12,200, and the mean here is bigger than 12,200. That's what the researcher thinks. Alpha is given. So the first thing I always do is find the test statistic. X bar minus mean over standard deviation over the square root of n. They give us all these numbers. All we have to do is just substitute them in. 12,895.9 minus 12,200. This is 3,800 and n was 35. I calculated this and I got 1.08. What does that tell us, the test statistic? This tells us how many standard deviations above or below, or depends on what kind of test. Here would be above because it's bigger. So this tells us that the sample mean of 12,895.9 miles is 1.08 standard deviation above the mean of 12,200. Just an interpretation what this Z value means. Okay, now we're gonna be use table 2 at alpha equals 0.1. So you go to table 2 and either in the front or the back of the book, and look in the body of the table for 0.1. And then from there you will find the Z value, Z sub alpha. The closest one I found out to be it's 1.28. After I find it, I draw the normal standard deviation like this, because the sample size is 35. So by the central limit theorem, it should be approximately normally distributed. And what we have here, I always label the Z sub alpha first on the graph. Z sub alpha, say it's here, Z sub alpha is 1.28. And it's a right tail test, so this is the rejection region. Rejection region. Now we are going to look at Z sub 0. Z sub 0, it was 1.0 something. So it's less than that one. So say it's here, Z sub 0. Did Z sub 0 fall in the rejection region? No. So Z sub 0 is less than Z sub alpha. Okay, so we do not reject or fail to reject H0, the null hypothesis. Okay, and what does that mean? How do you interpret this? We say there is the interpretation, there is no sufficient evidence. There's no sufficient evidence at the alpha equals 0.1 level of significance to support Patricia's claim that residents of the state of Montana drive more than the national average of 12,200 miles. It's important to read this and really get what the question or what this is saying. Okay, we can look at another example. So we have, according to the CTIA, the Wireless Association, the mean monthly cell phone bill in 2004 was $50.64. A market researcher believes that the mean monthly cell phone bill is different today, but is not sure whether the bills have declined because of technological advances or increased due to the additional use. So the researcher believed that the mean should not be 50.64. Shouldn't be like that. Okay. We test the claim by picking a simple random sampling of 12 cell phone subscribers and obtained the data, and they took the data and they put it in a table. So the data is 94.25, 38.94, 79.15, 56.78, 70.07, 15.59, 77.56, 37.01, 55 evenly 55, 76.05, 26.29, and 52.48. So these are the charges. Okay, so the Wireless Association thinks that the mean is about $50.64, but based on this sample of 12 subscribers, some they paid $27.29, some paid $115.59, depending on the use. Assume that the mean, the standard deviation is given as $18.49, and the level of significance is 0.05. We are going to test this claim. This is the null hypothesis. This is the alternative hypothesis, instead of writing them down. So that tells us it's a two-tailed test. That's the difference between this one and the previous one. Now, usually when the data is, first thing is less than 35, and it was no mention that this data was, this is a normal distributed. So to test or verify, let's write that down, to verify that the data come from a population that is approximately normal with no outliers, we construct the normal probability plot that we did in previous sections. You can go back and see it. We have to use technology to do that. So you plot these numbers and then see if there's any outliers or not, and review the section that deals with this one. Usually on the test we don't ask students to verify this. I usually state it up, but here, just in case if someone asks about it. So first thing we need to do is find z sub 0. It's x bar minus mu, the standard deviation over the square root of n. This was 65 point. The mean was, well, it's not given, but what we do, we need to add all these up and divide by 12. Let's see what we get. 65.014 minus the mean. The mean is 50.64. 18.49 divided by the square root of 12. That gives me 2.69. So that means the sample mean of $65 and 0.14 is 2.69 standard deviation above the assumed population of $50.65, because it's more, it's bigger. So now we need to find the z value. In this case, we call it, it's not going to be just z alpha, but it's going to be z sub alpha over 2. So alpha is given 0.05 over 2, that becomes z 0.025. What is that going to be? Well, let's look into use table 2 in the body of table to look for this number, and you will find that the z value is 1.96. So now we are going to construct the two-tailed test for the two regions. This one here is z sub alpha over 2, and again it's 1.96, and this one here is always the opposite, which is negative 1.96. Okay, so we have two critical regions or two rejection regions. What we need to do here is we need to find out what we got for z sub 0. Z sub 0 was 2.69. Where is that located here? So somewhere here, 2.69. 2.69. So notice where the z sub 0 value, it fell in one of those rejection regions, right? So this means we reject the null hypothesis. Okay, so this means if you want to interpret this, there is sufficient evidence. The researcher found there is sufficient evidence at the alpha equals 0.05 level of confidence to support the claim that the mean monthly cell phone bill is different from the mean amount in 2004, which was what was it, $50.64. $50. That's what this is about. So if they do the right, left, they go the same way. If they do the two-tail, you have two different regions. If the Z sub 0 falls in either one of them, we reject the null hypothesis. If not, then we fail to reject the null hypothesis.